So just before all the conspiracy theories start, I just want to quickly give you a 2-minute video on how aircraft holds are conducted. So what they will use is something very similar to this chart here. I'll just go through it very quick, and if there's any pilots that are listening to this, I appreciate that I'm oversimplifying this, but just roll with it please. So I'll start from the top then. So this is for Lafayette Airport. These are all the different frequencies for all the different people that you can speak to. Final approach course, so that's what heading the runway is going to be on, is 143 degrees, and if you look here, 143, straight into the runway. You've got a minimum sector altitude, so that's the minimum height that the aircraft can descend to, unless, providing that it's radar covered, so once it gets below that you won't get radar cover. And for those of you that are wondering about all the shapes in the sky, it is not chemtrails, it is caused by this here. So this is the holding pattern. So you have an aircraft that will use this here, which is a navigation beacon, which is a VOR, which it says up there, which stands for very high frequency omni range. Don't worry about that, it doesn't really matter, there's loads of different beacons that can be used. But what they basically use this for is a known space in the air, and they will use that as a reference. So basically they'll fly over the top of this, and then they'll start flying around this racetrack pattern here. Now the shape of this won't be exactly like this, because if they have a wind that's coming from this direction, see it's coming sort of easterly, it's going to blow them out this way. So the shape, rather than be nice and round, it's going to be more sort of bulbous. It go out like that, and then they come in. So that's why the shapes might not look perfect. If they've got a headwind, so if it's coming in this way, it's going to end up a lot shorter, potentially, and if it's behind, it'll end up a lot longer. So what they'll do is they'll come in, they'll fly around this pattern at different heights, and they could have aircraft stacked up. So you might have an aircraft at 10,000 feet, one at 9,000, then one at 8,000, 7,000, and all they do is they keep flying around this, and they'll either come up or down, depending on what air traffic control tell them to do. Then when they're ready to actually land, they'll come round, fly over the beacon, and then they'll head down this direction here, which is 143. What they have here is other markers, so D5 means it's 5 miles from here, 5 nautical miles that is. So the name of that marker there is Ipuke. Then you've got Battle, it looks like, that's 7 miles. So they know when they're at 7 miles, they should be overhead this point. There's another beacon here that they can use, and they can take bearings from that. So it's all quite complicated, it's all complex geometry. Then when they get to the 10-mile point, if we scroll down to the bottom, that's what they call the missed approach point, and that's if they can't see the runway at that point, then they've got to overshoot, go around, and that's what you've got this broken line here for. If you look at it graphically here at the bottom, so this is looking at it side on, this here is looking at it from above. So there's the holding part, so they've got to do that at a minimum height of 2,300 feet. That's the beacon I told you about, so that's this one here, so the VOR. They then, once they've been told by air traffic, they will then head out along this line here at 143 degrees. They'll get to this point here, Ipuke, at 5 miles. Once they get to there, they can descend. And they can descend down to 2,000 feet until they get to Battle, or Battle. That's going to be at 7 miles. That's called the final approach fix. So that's the final point that they will look at and make sure that they're overhead that before they make the approach. They can then descend further on this last section here into Maffei, and when they get to Maffei at 10.1 miles, if they haven't seen the runway or air traffic have not cleared them to land, they will then overshoot, they will climb, and they will come around, and away they go. So if they miss the approach for whatever reason, they'll look at this part up here, they'll climb to 2,300 feet, then a right turn direct to the Bravo Victor Tango VOR and hold. So that's the Bravo Victor Tango VOR here. So they come down, they would shoot around here, and then they go direct to here again, 2,300 feet. Air traffic control probably at some point here will tell them more than likely to climb higher, maybe 10,000 feet, 11,000 feet. So they come in with the stack at the top, because what you don't want is an aircraft that's lower having aircraft that are higher passing through their altitude, because that's when you've got a risk of a collision. And that is how aircraft land and use navigation beacons for holding. So hope that helped you. Hope that makes sense.